Let's have a look at algebraic fractions. This is a massive, massive thing, which is likely to come up in the next two papers. So there's just four things I want you to kind of go over and look at. You know, generally, if your kind of algebra is decent, this stuff isn't too hard, but I just want to give you a recap, and also there may be a few things which you're not 100% sure of. So, okay, the first thing is when you're asked to kind of simplify something like this. So this is not a solve, all right? So what this is similar to here, yeah, is actually kind of saying, hey, simplify 3 over 12. And you're happy you'd kind of divide both top and bottom by 3 and you get 1 over 4. Now obviously this does not look like that. So what do you do with this? The answer is you've got to factorize top and bottom. You can't divide top and bottom of a fraction when you've got like these little plus things in there or negatives and stuff. So let's have a look at that. If you get a simplify and it's a fraction, the answer is always factorize. I can go into detail in like a lesson or something if you want me, but this is like a quick fire video. So okay, so the top one will factorize into 2x plus 2 plus 1. Okay, my bad, I meant to do that as 2 by the way, yeah? Okay, so imagine that. So can you see you'd factorize that, and if you factorize this, you'd get x plus 2, x plus 1. All of a sudden, you have something where you can cancel one of the things off the top and bottom, and your answer in the end is just 2x plus 1, x plus 1. Okay, so that's literally how the first one works, and we can have a look at a few questions just so you can kind of get the hang of it as well. Okay, here you go. Hopefully you can kind of see those as well. I might as well get that out bigger, to be honest, just in case. I don't know how big this video is going to come out. Okay, let's snip those. Okay, so there you go. Let me do each one of these. So remember, you always factorize the top. That's x squared, by the way. Okay, so factorize the top. So can you see the top one? You just pull x out and you get x plus 5. And on the bottom, if you factorize that, you'll get x plus 5, x plus 2. So you see, you always get one. You're always going to get the same bracket, top and bottom. So your answer is x plus x over 2. And feel free, if you kind of look, don't feel like you have to watch all of this video. If you feel like this is making sense, you look at those, you're like, yep. Feel free to skip ahead in this video for when we get to the point which doesn't make sense for you. This one, just for the sake of it, you know. And did you know it's always factorized? It doesn't. On this one, it was a single bracket factorization. This was double bracket factorization. If you can factorize, just factorize it. Okay, so this one is gonna be minus 4 plus 3. Now, if I was in any way unsure about this, I know one of these is going to be 4 and 3 or something like that. So I should be like, well, 3 isn't going to divide into that. So I know there's probably going to be that, and I quickly find it's that as well. So I guess that becomes x plus 3, x over minus 5. This one, I would pull a 3x out, so I get x plus 3. And the bottom, this by the way, how do you factorize that? That's a difference of 2 squares. So that's x plus 3, x minus 3. Feel free to kind of look that up as well. Cancel. The answer to that was 3x over x minus 3. Does that make sense? Yeah. And then I just want to show you some particularly like ugly-ish looking ones. You know, where things start to look a bit, you know, might kind of go for. Yeah, say something like this, you know, here's 2 questions which are considered very tough. I just want to show you that it's nothing different, basically, which happens with those. So if I just move that over to there. Alright, let's have a look at the first one, simplify fully. So, again, like, can you see we've got 2 fractions, what's the word? Dividing, yeah? So what we still want to do with this, we always just want to factorize. So the top one, if we can take a 3 out, so that becomes 3x plus 2 over, we can't do much with that, that's going to be x minus 4. Now we're going to have divide, and now here we do want to do the, we still want to do the same, so we've got like x minus 4, I mean factorize that is. Factorize that, we get 2x, x, I'm obviously going to do this quickly. I think it's going to be 5 and 2. Yep. Okay, so that one, have I done that right? 2x. Yeah, good, okay. So now, I mean, feel free to cancel anything which you can, but there's nothing really we can cancel. Now, we're going to treat this divides exactly how we would with something else. So you just flip it. Flip it and turn it into a multiplies. So this now becomes 3x minus 4 over 2x plus 5x plus 2. And now we can kind of join this at the top. We don't actually want to multiply anything out here, guys. Yeah, because that will ruin the whole point of what we're trying to do. X minus 4. Should have really brought that x to the front, made it 3x, but you know. So I've got x minus 4 here, got 2x plus 5 here, x plus 2 here. So you can see that x plus 2 is going to cancel with that x 4, that, and the final answer I get is 3x over 2x plus 5. So it's exact, and I do mean exact same logic, except, yeah, you just divide it where it asked you to divide. If it had asked you to times, I would have timed straight. We'll do this one. I actually remember, by the way, as you do these videos, I recommend you pause everything which you think you can do, try it, and then resume it, and then check if you're kind of correct. Okay, 2x minus 1, can't do anything with x plus 5, divided by, what's this one going to be? X minus 3 minus 1. Okay, and this one, by the no, wait 1 second. Let's just do it. I'm just going to use a calculator. Okay, so that's going to be like a. What am I talking about? Plus 5. There you go. So we got that. Yeah, now let's do the flip. So you got 2x minus 1 over x plus 5 times 2x plus 3 x plus 5. And now you can already see that's going to cancel with that. On the bottom we're going to have x minus 3. Or whatever. Yeah, x minus 1. We can sort of join those, we can join this together, so you get 2x minus 1, 2x plus 3, x plus 5, all over x plus 5, x minus 3, x minus 1. See, that cancels with that, this cancels with that. And, you know, your answers, doesn't really matter how you write it. 2x plus 3 over x minus 3. You could have multiplied that if you wanted. It's not going to get you any marks. It's not going to lose you any marks. Yeah, so hopefully that makes sense. So that's how you can kind of just simplify any type of fractions. They kind of go, just treat them like normal fractions, but factorizing is really the big thing, okay? Alright, number 2. So if you know this, feel free to skip, but the one thing you want to kind of pay attention to, and actually let me change that to a 5, okay, is the way we always do either one of these solve any of these algebraic fractions is we always, you know, this bit here, we're going to try to join that into one fraction, and we're going to try to join that into one fraction. Okay, so let's have a look at the first one. So say you've got, so really what you do is you put all your focus, you don't care about this equals 6 yet. You're putting all your focus into joining these two things. Now, obviously, the reason these are easier because it's, you know, you need to get that common denominator, and it's quite easy to tell, oh, that's going to be 20, okay? But the problem with this one is, well, what the hell is that going to be? The way we can go about it, I mean, it's dead simple, is we would always multiply the first fraction by the bottom on the second, and the second fraction by the bottom on the top. Sorry, on the bottom on the first one. Okay, so imagine you had no idea that 20 could go into these numbers. Here's what you could do. You could say, oh, well, listen, I just need the bottoms to be the same. So if I just times this top and bottom by 5, because that's on the bottom, I times this bottom, top and bottom by what on the other one, I'm guaranteed to get a bottom, because doesn't 4 times 5 equal 5 times 4? Similarly, when you go 8x plus, well, that, yeah, over that. Now, that's in no way obvious, but what you're going to do is you can see, well, I could times this one by x plus 8, and I'll kind of get that double bracket, and if I times that by x plus 3, I'll get that double bracket. Okay, so let's just kind of do those. So this one you times by 5, so you technically kind of put it in a bracket. I mean, you could do it in one swoop. I don't like that kind of stuff. But I mean, you know, as long as you don't do anything wrong, it's fine. I'll be honest, I personally skip this when I do it, but you know, I'm not taking the exam, so it doesn't take long. Okay, so you just kind of multiply out, you get to that 8x, and you know, what's it going to be? Minus 12. Important thing here, by the way, always look out for this minus minus. That means you're taking away a minus 12, so it is going to become positive. So 15x minus 8x, so you get 7x here. 25, take away minus 12, well, that becomes an add, so that should become plus 37. The mistake which everyone makes is 25 minus 12, and they just write 13. Well done, dude. Okay, so you get to that. Now, if you look at this question, it's actually pretty easy from here. You go equals 6, you just times by 20, you get 7x plus 37 equals 120. And it, you know, it's no rocket, so take away 37, divide by 7, you got that, okay? Hopefully that makes sense. Now, this obviously is the one which I'm more actually interested about. So if you kind of do this, if I just kind of take it to here, because I've done it too low, can you see it's, I get to this stage, I've got x plus 3, x plus 8, plus 3x plus 3 over the common multiple. Sorry, common denominator, yeah? So obviously I can kind of like multiply the top out, I get 8x plus 64 over all of that, which I can multiply out if I want to, probably should. Okay, so you get to that, you get 3x plus 9. Okay, so now you can join them up, because the difficulty was just that bit, but it's literally as simple as that every single time. So 11x plus 73 over x squared plus 11x plus 24. Okay, and you know, from this point on, remember, that's where you've kind of joined that. So essentially what you're doing is you're rubbing that out and putting that in. So now you can just carry on with the question. So multiply your whole quadratic over. So get 11x equals 73 equals x squared plus 11x plus 24. Now can you see what this one becomes, by the way? And these ones are usually 6 marks when they come up, yeah? And it's because it turns now. So not only is that kind of sort of hard enough, but this is now going to turn into a quadratic. Well, actually, this one isn't going to solve much because you got 11x and 11x, yeah? So you could take away those. You could take away 73 and all of that. Basically, it becomes a quadratic. I mean, this isn't the best one, to be honest. So you get x squared. So was it 24 take away 73, which is minus 49 equals to that. And there's 2 ways of solving that. I guess you could kind of do difference 2 squares, so you could see that as x plus 7, x minus 7 equals that. So x equals 7 and minus 7. Should have really been the opposite way around, but you get that. Or you could just kind of turn it to the other side, go 49, x equals square root of 49. But don't forget, square root of 49, it's 7 and minus 7. Okay, so you've got to give both answers for that one. Now, let me show you a better one than that, because that one just sort of, you lost, you know, that 11x and 11x cancelled out. But basically, make sure you kind of, that won't always happen, by the way. So you've got to be good on your, make sure you're solid on your quadratic formula, because really, by doing, you can always solve a quadratic formula. So you can always solve a quadratic using a quadratic formula. That's what I meant. Okay. So I don't know why they're saying 4 marks. I don't think there will be 4 marks. If they can't, they're going to be more than that. But this is just like a sheet anyway. So let's go for this one. Hopefully this one actually gives me something a bit different. Gives me, so if I go for that, okay. So if I got 8 over 3x minus 2 plus 6 over x plus 1 equals 2. So I just I don't even care about my equals 2 right now. I want to get this common denominator. So can you see this first one I'm going to times by x plus 1. The second one I'm going to times by 3x minus 2. Okay, so if I kind of do that, I get 8x plus 1 over 3x minus 2 x plus 1. You know, hopefully you're kind of pausing this and kind of going along with me as well, because it'll drill it into you. And once you get it, it's fine. When you don't get it, it's an absolute nightmare. It's got 8x plus 8 over all of that, 3x squared. 3x squared plus 3x minus that, so was it minus x minus 2 plus 18x minus 12, 3x squared minus x minus 2. Obviously it's going to be the same. I don't know why I actually thought about it twice. 26x 8 minus 12 minus 4. Okay. 3x minus x minus 2. Hurrah! I've actually joined it. So now it's almost like, you know, like I could literally just replace all of that with 26x minus 4 over 3x squared minus x minus 2 equals 2, you know? So obviously now, I'm going to times both sides by that just to get rid of the fraction. So I get, if I just kind of take it over to here, I've got 26x minus 4 equals 2 bracket 3x squared minus x minus 2. Let's multiply. Basically, I'm going to get a quadratic now. So, you know, 6x squared minus 2x minus 4 equals 26x minus 4. Remember, every quadratic has to equal 0. So let's take away 26x from each side. God, this getting messy, isn't it? So if I can bring this over, I'm going to have like minus 4 equals 6x squared minus 28x minus 4. Now let me add 4. Oh, flipping out. They've had this number cancel out as well. Add 4. Add 4. So that would go. So you get like 6x squared minus 28x equals 0. This one's just done by, you know, you could take, what, 2x out and go like 3x minus 14. Not very happy with that. So your two answers, by the way, don't forget, this one gives you x equals 0. This one will give you like 14 over 3. My point, the reason I'm a bit annoyed with that one is, you know, can you see, imagine if this was like minus 10, yeah? If you had added 10, you would have just got 6x squared minus 28x plus 6 equals 0. And you would just solve that like your normal quadratic. It's kind of annoying that it hasn't happened. But do you see how it kind of goes? You've just got to get the common denominator, and then it will always turn into a quadratic. Whoops, didn't know what happened there. Oh no. There you go, back again. Alright, you know what, let me skip to the last one, this one, and fingers crossed, come on, like it actually gives us what we want. There you go. Okay, so the first thing we want to do, so we've got 7x, no, well we haven't, 7 over x plus 1 minus 3x minus 2 equals 1. We don't care about this right now, we're just going to join that. And do this, pause this, do it as I do it. So we're going to times this fraction by 3x minus 2, we're going to times this fraction by x plus 1. So we get 7 3x minus 2 over x plus 1, 3x minus 2, minus 4x plus 1 over the same thing, x plus 1, 3x minus 2. If I multiply that, I got 21x minus 14 over 3x squared minus x. Is that the exact same one? Minus 2 minus 4x plus 4 all over the same thing, 3x squared minus x minus 2. Let's clean it up. So 21x minus 4, 17x Be careful here. This is minus 14 minus plus 4. So that's 14 minus 4. So that's going to be minus 18. And you've got your 3x squared minus x minus 2 equals 1. So now this is going to go into, we're going to times both sides by the bottom of the fraction. So we get 17x minus 18. Obviously that's times 1, so we don't have to, we just put it there. Which, by the way, at any time you could just kind of like switch over. You can switch sides whenever you want in any equation. So you may kind of feel like it looks nicer there. Take away 17x minus 18x minus 2 equals minus 18. Add 18. 3x squared minus 8 plus 16 equals that. And then just solve that like a quadratic, And quadratic formulas are going to be your best bet. It's just the one which is, foolproof. But I don't know, you might like that doesn't look very nice at all. Okay, and then if you solve it using quadratic formula, remember, minus b plus or minus b squared minus 4ac over 2a, which I'm not going to bother doing here. You basically get two answers, 4.915, and you get x equals 1.0851. Okay, so to be honest, there's no way you could actually do that using factorizing, because you'd never be able to spot those numbers. But yeah, I mean, that's actually usually a good way. So if a question can't be done by factorizing, when it gets a quadratic, it'll say something like give your answer to 2 decimal places, which is basically saying there's no way you're going to factorize this. You're going to have to go to quadratic formula. But does that make sense? Okay, and finally, we're virtually actually done. This last thing doesn't take much at all. And it's just kind of like, so what they like to sometimes do is they like to give you this kind of like ratio thing. So they might kind of say, they could actually say to you, solve, or they could say that, the ratio of x to x plus 3 is 2 to 3. And then they're like, find x. And you're like, what is this? Like, I've got a ratio with algebra and stuff. Now, here's all it basically just says. If you kind of think of like x to x plus 3, it's got a, it's like the ratio is 2 to 3. So for every 2 things here, you got 3 things here. So, I mean, here's the logic behind it, okay? So you have no clue what these numbers could be. So, like x could be 2 and x plus 3. I mean, I don't know how. It could be 3 because we don't know what x is. Well, no, that wouldn't make sense at all. Just realised I'm giving you like a very, very bad question, actually. Wait, what am I talking about? Okay, ignore that. That question makes absolutely no sense because I didn't think about it. So imagine if you had something like 2x plus 5 to x plus 7 equals 3 to 5. So it's saying, or if I had 2x plus 5 and I had x plus 7, yep, the ratio is 3 to 5. In short, it's not like you need to make an equation if you're going to try find x. I mean, the problem is you don't know this equals 3. Otherwise, you could just say 2x plus 5 equals 3, and you don't know this equals 5. Because whilst the ratio is 3 to 5, I mean, the real numbers could be 6 to 10, could be 9 to 15, any of that. So you can't make an equation of it directly, but here's what you can do. You can always do this divided by that. So you can say 2x plus 5 over x plus 7. That's always going to give you 3 over 5. Because even if this is 6 over 10, can you see you get 6 over 10, which will cancel down to that. That's an equals, by the way, yeah? And you've got an equation, which you can solve. So what you can start off by doing is you can kind of times both sides by x plus 7. So you get 2x plus 5 equals 3 over 5 x plus 7. You could times this side by 5. So you get 2x plus 5 equals 3x plus 7. And then you can multiply and solve it like that. But my point here, the biggest point is, if they give you, to be honest, you can even skip what a lot of I kind of said. It's always going to be this divided by that is going to equal this divided by that. And the reason I show you that, it's just like if they throw a question, hardly anyone can ever do this. And let's actually kind of have a look at a few tough ones now, just for the sake of me kind of showing you how you can always go about and just use the same thing every single time without fail. So okay, here's one. So they said that 3x plus 5 to x plus 4 is equivalent to 2x plus 4 equivalent to to x plus 2. And it goes find the possible values of x. Now, find the possible values of x, that's an interesting thing actually, because it's like it's not going to give you one answer. So how could that happen? Probably going to be a quadratic, because that's usually where you get two answers. But anyway, we don't even care about that. Here's what we do. We say that, oh, we don't know what it is, but we do know that 3x plus 5 over x plus 4, literally this divided by that equals this divided by that. And that's it. 2x plus 4 plus x plus 2. Multiply that side by x plus 4. This is that, you know, you might have heard of cross multiplying. I don't like the idea of cross multiplying. So we get that. We multiply by x plus 2. So we get 3x plus 5. X plus 2 equals 2x plus 4. X plus 4. Now can you see you're going to multiply it out, so you get 3x squared plus 6x there, so plus 11x there, plus 10. Take your time, obviously. I'm just going to skip them through. 2 squared plus 8 plus 12x plus 16. And now what's happening here is this is going to be another quadratic. So we're going to make this side equal to 0. So we're going to take away 2x squared. So can you see that's going to give us x squared. We're going to take away 12x. You should do this in more than one step. So you get minus x there. Take away 16. That's going to give you minus 6. Give you that. Okay, that's a quadratic. You know. So you can either use quadratic formula, or if you can see that it factorizes quite nicely as well. Minus 3 plus 2. So your possible values are x equals 3 and x equals minus 2. Okay, so that's if they give you this this thing here. I'll do one more, and that's, to be honest, that's all your quadratic algebraic equation stuff done. Feel free to skip until I actually kind of start the question. Let's just go right to the hard one. Okay, so it's literally as simple as that divided by that. So we know that 5 minus 3x over 9 minus x equals 3x plus 7 over 4 minus x. We do that cross multiply thing, so you get, it's always going to be that times that equals that times that. And this is just the case now, multiply out. So you got 20 minus 5x minus 12x plus 3x squared equals 20, mind blank there, 27x minus 3x squared plus 63, whoops, minus 7x. Let's just make one side equal to 0. Well, we might as well clean some of this stuff up. So 20 minus 17x plus 3x squared. Now, what the hell am I written there? Might use 17x plus 3x squared equals 20x, because remember that and that will join, minus 3x squared plus 63. I'm going to do a little bit of a lazy skip. So we add 3x squared to both sides. So this side is now going to end up having 3x squared. So we've just done that and that. Yeah. For this one, we're going to take away 20x here. So we already got minus 17x here. So we get minus 37x. That's that sorted. And then you got positive 20, and we're going to take away 63, so you get minus 43 equals there. Oh, that doesn't look very nice at all. That's where we just kind of stick it into you know, the quadratic formula. Yep, and there you go. You get the answers of x equals minus 1 and x equals 7 and that sixth. Yeah, 7 and a 6. I do the calculator. You know how much I hate mixed fractions anyway, so you would have probably got it as 43 over 7. That's that, which is also the same as 7.1, 6, 6, 6, 7, all of that. So we actually did factorize as well. Factorized to like 63, and that was like plus 1 minus 43. So yeah, I mean, the good thing about, you know, the calculator papers is quadratic formula. You don't even have to think about it. Can you spot it? Can you not? But yeah, there you go. Okay. Yeah, top stuff.